Welcome to Calculus, the class you've been looking forward to and didn't really know it. So let's talk about calculus. Make sure that we're on the same page here. Calculus is all about finding infinitesimal changes of slopes, meaning finding the slope between two consecutive points. Now the word infinitesimal means so small you can't even see it. In fact, so small that they actually aren't. There is no space between them, basically. You can't see it. Bottom line. Points are dimensionless positions on a graph. If you, in geometry, you found that points had 0 dimensions, lines had 1 dimension, just length. Areas like a square or a rectangle or a circle have 2 dimensions, length and width. And on. Points have 0 dimensions. They are not ever completely 100% defined. It's just right about there. So 2 consecutive points are impossible to see or to define, but in theory they exist. Now when I say theory, the word theory means in actuality, proven as such. Okay? Don't misconstrue that word with hypothesis. A lot of people say, oh, that's just a theory. No, what they really mean to say, oh, that's just a hypothesis, they just think theories are not proven. They are. Hypotheses are not. It is proven that points exist. That's how we get lines, and that's how we get areas, and how we get volumes, and all that. They're all filled with points. So please, get the point. In order to find that slope, we have to find the limit of a function. Straight line graphs are really easy to do because no matter what 2 points you pick, you're going to get the same value of the slope. That's simple. However, when you have a curve, you're trying to find the slope at a point on the curve. You will need to find another tool because any 2 visible points will most likely give you a different slope each time. Okay? So, that's what calculus pretty much is based upon. Now, calculus was developed by Sir Isaac Newton in the 1700s. About the same time, a German scientist by the name of Wilhelm, I don't remember, Leibniz. But they pretty much came up with this idea of infinitesimal points and how the closer you get together between 2 points, the more accurate the slope is going to be. So this class is going to be a quantum leap in intellectual thinking for all of you. I will guide you through this as I have in Chem 1, or I'm sorry, Chem 2 in physics. But you have to buy into the imagination that is the basis of so many applications. You have to kind of visualize what they're talking about. I am always available to help you through any question you may have. And I'm sure there will be questions, and I will try to find more than one way to explain it so it will make some semblance of sense to be illiterate. Now, dealing with the language of calculus is like dealing with the language of lawyers. There's a lot of special language they put in that actually means things that we take for granted, but they put it in there to make sure you understand that this has to be accounted for. So, like when you try to read some legalese document like rules for using a website or whatever, you don't read it because it's blah, blah, blah. You get the general idea. I'm part of the town council. We have to deal with an engineer developing our water system or redoing our water system in town. And the contract with this guy is blah, 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 blah. And the other members of the village board say, I can't read this. And I said, you can read it. You just have to ignore the extraneous words that are there to A, either confuse you, or B, cover their butts in case something happens. But get the large picture of it. That's what is most important. And that's what we're going to be doing here. Because a lot of this is variations upon y equals mx plus b. It's that simple. So let's get started. As I said, You learn the equation y equals mx plus b for determining slopes from equations. But you can also find the slope, as you well know, by taking 2 points using the equation y2 minus y1 over x2 minus x1 equals m. So subtract the y's, subtract the x's in the same direction, divide them out, you get your slope. All slopes are found this way. But since we are using the absolute minimum distance between 2 points to emphasize this little fact, the powers that be in calculus will change up the variables for that emphasis. So that's what you're going to have to follow. So while you're listening to me and you're daydreaming and all that stuff, you're going to miss out on the stuff that is kind of important and will keep from confusing you. So stay with me. I'm hilarious when you get to know me, and I will bring in points along with my hilarity. Okay, I'm not that funny, but you get that. So let's go to our textbooks, and let's find problem number 7 on page 47, shall we? Okay, so we're on 47. We're taking a look at problem 7. And this is about secant lines being drawn on a graph of 4x minus x squared and the point 1, 3 on the graph of f. So, now this is the point we're making about how you pick 2 points. Let's say this, we're looking at a particular point here, and we're drawing what we call secant lines from this point to another point on the curve. And each time we do that, the slope gets closer and closer to what it actually is, which is the tangent of that point on that curve. So the closer and closer the points get together, the more likely that it's going to be either represent or come close to be the actual slope of the tangent red line that I have here. Now in problem number 7, we're going to do that. Problem number 7, the equation for the function is 4x minus x squared. Now, when I say function, this is a mathematical term that basically says that a function is a one-to-one relationship that for every 1x there will be exactly 1y. So y and f of x are exactly the same thing. I don't know if you remember that from Algebra 2 and pre-calc, but that is a very important point to remember. Don't get confused by the f sub x, because that's another one of those goofy things that they came up with to describe that. But it's goofy in the idea that is basically a direction as to what you're supposed to do with the number inside here in relation to the x that you have here. Perform the mathematical operation, and boom, you got your y. So if you put in 1 for x, you get 4 times 1, which is 4, minus 1 squared, which is 1, 4 minus 1 is 3. So the point being represented by that particular one is the point 1, 3. So there's your point 1, 3 right there. Okay, now, it asks you to find f of x, and for x is 2, x is 1.5, and x is 0.5, and then to plot the points. So you take that equation, plug in 2, 1.5, and 0.5 for all those, and you get 4 for y, so that becomes 2, 4. For this one, for 1.5, you get 3.75, so you put 3.75. And then for 0.5, you're going to get 1.75. So 2, 4 is this point right here on top. It's what we call the apex of the curve. 1.5, 3.75 is halfway between the 2, the 1, 3, and that. And then 0.5 and 1.75 is over here. We draw secant lines from 1, 3 to those 3 points.